see here, negative 20 divided by 2,500, negative 0.08, negative 0.008, excuse me, negative 0.008. So I'm just going to take my A value and my H and K and plug it back in. So my equation will be y equals negative 0.008 times x minus 50 squared plus 35. Some of you left the fraction instead of negative 0.008. I think it was 1 over 125. That's fine if you leave that in fraction form. So mostly good stuff on that. All right, solving quadratics is what we're getting into today, and it's going to be what we're into for the rest of the week. There are several ways for solving quadratics. Sometimes some of them work better than others. Probably the favorite way of mine is one of them we're going to get into at the end today. It's by factoring. That's what I like to do the most. Quadratic formula will be later in the week. That's probably the most famous way because we get to sing a song and learn the quadratic formula. So that'll be coming up. Graphing is a way to solve. Completing the square is a way to solve. Factoring is a way to solve. Using square roots is a way to solve. Using the quadratic formula is a way to solve. So there's tons of different methods. Sometimes some of them work, sometimes some of them don't. So you got to know when each one works and when they don't and all that kind of stuff. Some words that you need to know that go along when we're solving quadratics. When we're told to solve the quadratic, that could be, the answers could be called roots, zeros, what else are they called? I think that's about it. No, that's all I can think of right now. And it never fails. Every time somebody's taking any kind of test, they'll say, what's said to find the roots? And I didn't know what they were talking about. This is just different ways of saying the solutions. Solve, the answers, the solutions. Now, when we're talking about a quadratic, and we know this from last section, all the graphing we did, it's a parabola. Okay, so our options are, it could have two solutions, because a solution is everywhere it crosses the x-axis. So we see a parabola like that would have two solutions, right? Our parabola, if it just hits the x-axis, either up or down, could have one solution, right? We could have a parabola that has no solution because it's never going to cross the x-axis. So it's possible to have two zeros, 1 0, or no zeros. Those are the different options for our answers, and that's where they come from. Okay? Alright, first thing we're going to do is solve one by graphing. We're going to it'll be like a review over last section where we graphed them all the time. Graphing, in my opinion, which doesn't count for anything, but it's the least accurate way, because a lot of y'all are going to have graph paper, and so your spaces might not be all equidistant and everything, and you might get off on your counting. So unless you've got all the proper tools and supplies and everything, sometimes graphing is the least accurate way. But last chapter, look, I'm going to do chapters in here, last unit of stuff, when we did intercept form, remember that? X minus P times X minus Q, those intercepts would be those solutions right there, right? Okay, a couple of y'all are on board, a couple of y'all don't have a clue. Let's look at x squared plus 3x minus 10 equals 0. And I'll move this out of the way. Let me get my graph paper up there. So we're going to do one by graphing. Alright, directions on this say solve the equation by graphing. So we're looking for where does that parabola cross the x-axis. Solve the equation by graphing. We're finding its roots, we're finding its zeros. We learned 3 forms of a quadratic last unit. What were they? Tell me one.
Standard.
Vertex, standard, intercept. Very good. Which of the 3 is this one? Standard. Very good. When we're going to graph in standard form, first thing we would have to find would be the vertex. We start doing that by our negative b over 2a. Okay? That stuff we did last unit will not go away. The stuff we're going to do today will not go away. Quadratics, if I said what is the major theme of Algebra 2, quadratics is up there at the top. May not be the biggest, but it's pretty close. We will do quadratics throughout the rest of the year. Okay, so this stuff's got to carry with us and stick with us. My A is 1, my B is 3. So x equals -3 over 2 times 1. So my x is -1.5. Right? Are you okay on that?
Can we put it as a decimal?
Yep. So I'm -1.5. There's my axis of symmetry. How do I find the vertex of that? The y part. Plug that back in. So I'm going to have -3/2 squared plus 3 times -3/2 minus 10. That's 9/4. I like this. Minus 9/4. Right? Everybody see that? Y'all okay? Need to talk about that? Everybody good? When you square a fraction, you square top and bottom. 3 squared, 2 squared. When you multiply fractions, you just multiply across the top. 3 times 3. Across the bottom, 2 times 1. Everybody all right on that? This is why I said I liked it. Those fractions, 9/4 minus 9/4 is nothing. So I just have -10. Okay, so the vertex on this is -1.5, -10. Now, I'm fixing the. Did y'all get that? What y'all do?
I guess I've changed. I thought 3/2 is 1.5. I guess
It is. 3/2 is 1.5. Did I do something wrong? It's possible.
Over 3.
I see what I did wrong. I just found my mistake.
I got because I had it as a decimal, and when you plug it in,
Okay, I see my mistake, and I even said it. And nobody caught on to it. Anybody see what it is now? What's 3 times -3/2? Right. That should be right here. That should be minus 9/2, not minus 9/4, right? Because you multiply straight across the top. 3 times 3 is 9. Straight across the bottom, 1 times 2 is 2. So I should have 9/4 minus 9/2. So now I'm not as excited because my fractions don't cancel out. That'd be 9/4 minus 18/4, which is -9/4 minus 40/4, which is -49/4. What's -49/4 as a decimal? -12 1/4. My bad. All right. Now I'm gonna -12 1/4. Now I'm gonna mess my graph up a little bit because I counted on the red lines on the x-axis so that you could see the half. But to have any chance at getting -12 in, I'm gonna have to count on every line on my y's. So I counted 1.5, but now I'm fixing to count 1, 2, 3, 4, 5, 6, 7, 8. About like that, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 1/4. All right. How do I find another point on my parabola now? Plug in a different number. How about if I plug a 0 in? What would that give me? Should be able to do that quick. If you plug a 0 in, that's gone, what's left? -10. I think that's the bottom one with page 3, 4, 6, 8, 10. Alright, that is 1.5 away, so 1.5 away on the other side. Alright, I'm going to draw. I haven't found my answer yet, but I'm going to draw. No, I'm not. I'm not going to draw. I want you to visualize a little bit for me. If we're drawing this parabola, I'm not connecting mine yet because I'll screw it all up. But remember, I'm looking for my final answer on this is where it's going to cross the x-axis. This is going to turn up, so it's obvious to me it's going to have 2 solutions. So I need to get closer up here. So this 0 got me down 10. So what about, like, what can I plug in over here on the x-axis that'll get me closer to 0? Like, plug a 5 in, a 4 in. What's a good guess on what to plug in that's going to get me up there closer? 5. We'll plug a 5 in. So it's going to get me 5 squared plus 3 times 5 minus 10. That's pretty good, David. 25 plus, well, not exactly. 15 minus 10, that's 40 minus 10. Just 30. So that one went way past. So over 5 and up 30. So I need something between 0 and 5. So 3. 3 squared is 9. 3 times 3 is 9. That's close. 9 plus 9 is 18. Minus 10 is 8. So 3, 8. So we're getting closer. So this would be over 3 and up 8. So it'd be right there. So somewhere between 0 and 3, it's going to cross the x-axis. Courtney said 2 a second ago. 2 squared is 4. 3 times 2 is 6. Plugging in x's, trying to find where it's going to cross the x-axis. So I plugged in a 0 to the equation, and I got negative 10. I plugged a 5 in, and I got 30. I'm looking for a y of 0. I plugged a 3 in and got 8, so I'm getting closer. I plugged a 2 in. 2 squared is 4. 3 times 2 is 6. Minus 10. 4 plus 6 is 10. Minus 10 is 0. So there's going to be a 0. Over 2 and up 0. Now, I can go to the negative side and start guessing negatives and plugging them in. Or I can use the same method we did when we graphed these things last unit and see where would it have to be symmetrically. Okay, this is 1, 2, 3.5 away from the axis of symmetry. So I'm going to go a half, 1, 2, 3 away on the other side. Okay, so now you can see there's your parabola. Let me get a new color. There's your parabola. Okay, we were looking for the 2 solutions. That is where it crossed the x-axis, so that's negative 1, 2, 3, 4, 5. So x is negative 5 and 1, 2. There's your 2 answers, negative 5 and 2. Well, and that, I do not, come in, I do not do that, use that method often. That's my least favorite. I want to show you that same equation the way I would have worked it. Okay? It's my responsibility, and I try to best I can to show you all the methods, and then when it comes test time or ACT time or whatever, homework time even, then you can do your favorite thing. You do not, I'm not the, and I told you this on day one, I'm not the one that shows you this is how it has to be done every single time. If there's more than one method and you're better at one or you like one better, then you can use it. That graphing there I would have not done. Okay? Now, I'm only going to show you one other way today on this one. But throughout the week, we're going to learn lots of other ways. And then when it's all said and done, you can pick your favorite. We're going to learn how to solve that using completing the square, which I would not do. We're going to learn how to solve that using quadratic formula. I like quadratic formula okay. We're fixing to do it factoring. If stuff is factorable, that's what I do every time. Now, the reason I said that is because not everything is factorable. So it doesn't work every single time. That's why you got to know the other methods in case. Okay? So to check and see if this thing is factorable, remember this is standard form, ax plus by plus c equals, I just tried to mix linear and quadratic together. That's not, it's ax squared plus bx plus c equals 0. My first period class is doing linear, and I'll try to mix those together. Anyway, I look at my a. In this case, my a is 1. I'm going to do a times c, so 1 times negative 10. I need the factors of a times c, which mine is negative 10, 1 times negative 10, that add to b. My b is 3. So I need the factors of negative 10 that add to 3. Okay, you know them already, but I'm going to go through and show you what I'm talking about.
So your factors of A and C have to equal B.
Some of them have to equal B. Negative 10 could be 1 times negative 10 or negative 1 times 10. It could be 2 times negative 5 or negative 2 times 5. Are there any other ways I could multiply whole numbers and get negative 10? No. Okay, so do any of these pairs add to 3? 1 plus negative 10 is negative 9. That's not 3. Negative 1 plus 10 is 9. That's not 3. 2 plus negative 5 is negative 3. That's not 3. Negative 2 plus 5. Ding, ding, ding. That's 3. Okay?
Okay, I'm completely lost.
A times C, 1 times negative 10. The factors of that add to B. So the factors that add to 3. Because we're going to solve this by factoring. That's the method we're using right now. Now, that started off, this thing has 1, 2, 3 terms. That's called a trinomial. A trinomial factors as 2 binomials. Okay? So if I'm going to take this and break this apart here, x squared would have to be x times x, right? That's not rocket science. To get x squared, it's got to be x times x, right? The rest of my binomials comes from those factors I just found. I had a negative 2, so I put a minus 2 in there. I had a positive 5, so I put a plus 5 in there.
And we're done.
Huh?
And then we're done.
No? We're close, though. We're close. Okay? I'm not... maybe I need to. I don't know. I'm not going to make you check that right now, but so you understand what we're doing, this would be, remember last unit when I did FOIL? Multiplied those together. If I multiplied these together or FOILed them, it would be this. These are the same. I just factored it and wrote it in a different way. Okay, so now I can take both of those factors and solve them. Because if I took my first one, x minus 2, set that equal to 0, what does x have to be? There's one answer. I took my second factor, x plus 5, set that equal to 0. There's your 2 answers. Those are the same 2 we got on the previous page when we were doing all that graphing crap, graphing stuff.
Is that all you have to do? Why don't we do anything else then?
Well, everything won't factor. You're not always going to be able to find the factors of AC that add to B. Everything won't factor.
Will it work most of the time? Yeah.
A lot of the times. Anna.
I don't understand the first part. Like when you add them to... I don't
Okay,
even know what we're adding.
You have, this is 1, right? There's no number in front of it. So you take your A times C, 1 times negative 10. And what times what gets me negative 10? Well, you could make 1 times negative 10 equal negative 10. Negative 1 times 10. 2 times negative 5. Negative 2 times 5. Those are the only options that I could multiply whole numbers to get me a negative 10, right? Okay, so out of those, I got to look and see if any of those add to my B, which in this equation, my B is 3.
How are we gonna know? We just have to know like one negative.
No, you gotta know factors of numbers, yeah. What times what makes 10?
Oh.
Yeah. Gracie?
So do you need 10 over negative 10 over 3? Because that you wrote AC divided by B.
No. This, I'm sorry, that does look like that. No, that's not what I meant. I needed the factors of A times C that added to B. I don't know how to write that better.
A plus C equals B? Yeah, that's
No, it's not A plus C.
Wait, I thought you said
You said the best C.
I thought you said it was. I thought you said the sum of A plus C.
Yeah, you didn't say
That's
A plus C.
no, because my A and C here are 1 and negative 10. So A plus C would be negative 9. No, that's not how you would say that. I know what you mean, but that's not technically how you would say that.
So we're not getting X.
So what is it then?
The factors of A plus C. The factors. It's got to be. We're going to do another one. Y'all are trying to make it.
So you add A and C?
No, A plus C would be negative 9. I do not add A and C.
So what do
I
you
add
do?
the factors of A times C.
Okay, so you multiply A and C.
Yeah, A times C. I said that. All right, let's try another one. See if we can get it figured out. This one says x squared minus x minus 6 equals 0.
Is this about backwards?
That's what we're fixing to do, yes. All right, what is the A in our equation? 1. What is my C?
Negative 6.
So I'm going to do A times C, which is negative 6. Everybody okay? Everybody good? A times C is negative 6. I'm going to list my factors now of negative 6. What two whole numbers can I multiply together to get negative 6?
Negative 1 and 2.
Negative 1 times 6 will work.
1 times negative 6.
1 times negative 6 will work.
Negative 2 is 3.
Negative 2 times 3 will work. 2 and negative 3 will work.
So
Now I need to find if there's a pair of those, because there's not always going to be. Is there a pair of those that will add to my B? What is my B? Negative 1. So negative 1 plus 6 does not equal negative 1. 1 plus negative 6 does not equal negative 1. Negative 2 plus 3 does not equal negative 1. 2 plus negative 3, ding, 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 equals negative 1.
I'm sorry, where did you get your negative 1 from the start?
B.
Oh.
All right, so now we've got our winner. I know to get an x squared, I got to be x times x. I had a positive 2, so it gets a plus sign. I had a negative 3, so it gets a minus sign. Does it matter what order I put those in, the positive 2 and the negative 3? Nope, doesn't matter at all. All you got to do now is solve those factors. X plus 2 equals 0. Means x is negative 2. X minus 3 equals 0. Means x is 3. There's your two answers.
So basically, once you get your 2 points, you just switch the sign.
Nope, because it's not always going to be a 1x, and that will change that. As long as the A is a 1, yes, but it's not always going to be that. We would have to divide by 2 after that.
Why don't we just do 2x plus 2?
Well, if you had that, what I was telling her is that adds another step to your solving, because then you would have to divide, right? So it makes it be a 2-step equation to solve. Bing.
If it was 2x.
What is that?
You have to. We'll do one. Hold on. So when the factory starts getting a little bit more complicated.
I wanted to ask you that. Whenever you said the factor signs, if you had 2x squared and negative 6, the negative 12. I was confused.
Okay, you'll be quiet. Alright, let's look, and we're going to stray away just a moment and then get back. Let's look at 4x squared minus 31 equals 49. 4x squared, just be quiet. 4x squared minus 31 equals 49. The directions just say to solve the quadratic. Okay, first off, what is your b in this equation? 0. Good, David. A lot of people will start saying negative 31 on that. There is no x to the first power, so there is no b. Okay, so this is just a basic solving an equation problem. Here, I want to get the x all by itself. It's got 31 being subtracted, so I want to get rid of that. What do? Add 31.
You said the b is 0.
So it gets me 4x squared equals 80. Try to solve for x. It's being multiplied by 4. So what do? Divide by 4. So it gets me x squared equals 20.
Do the square root.
Okay, yeah, I knew squared by square rooting, and this is something y'all where some people have a harder time at. We're gonna leave our answer in radical form, and here's why. When it's not a perfect square, like 3 squared is 9, 4 squared is 16, 5 squared is 25. If it's not a perfect square, that's an irrational number. That means the decimal goes on forever, so you would have to round somewhere, and that's not exact. So for today and for a little while, we're going to give exact answers, which means we got to leave our answer in radical form. So if I'm looking to undo that squared, I'm going to square root it. Now, first thing I need to know, notice that sign I put out there in front. When I square root something, I can have a positive or negative answer. Okay, you make sure you understand that. Here's just a side note example. 4 squared is 16. Negative 4 squared is also 16, right? 4 times 4 is 16. Negative 4 times negative 4 is 16. So when you square root something, it could be positive or negative, right? Alright, 20. I'm looking for the biggest perfect square that'll go into 20. There I just listed the first 5 perfect squares.
So it would be 4.
Okay, 1 will always go, so you don't ever check 1. 25 is too big, it's bigger than 20. Will 16 go into 20 evenly? No. Will 9 go into 20 evenly? No. Will 4? Yes. So I'm going to rewrite this as whatever 4 times what makes 20? 5. Okay, now, so that's still the same thing, right? 4 times 5 is 20, so I haven't done anything stupid. I just rewrote it. Reason I did that, I had to find a perfect square. What's the square root of 4? What times itself equals 4? So this is going to be square root of 4. This is the way I always say this. Square root of 4 is 2, so 2 gets to come outside and play. 5 doesn't have a perfect square. He has to stay in the house. Those are your answers. Square root of 4 was 2, so it got to come out. 5 doesn't have a perfect square. It stayed in the house.
Couldn't you just do it this way instead? That's what we did in geometry. Because back in 20 or 2 and 10, then 2 and 5, you have 2.
That it is a negative. We just say it plus or minus. Positive, negative.
So that's just your answer, x equals plus or minus 2 squared.
at that one by yourself. Go. This one you don't have to simplify the radical. It's a perfect square. This one will work out with no radical in it. All right, what was the first thing you did? Then what? Then what? Should have slammed the brakes on. Why should we have slammed the brakes on right there? No, we had 20 and 20 wasn't a perfect square. It doesn't have anything to do with not being a perfect square. It has to do with the negative. What is the square root of a negative number? No.
Well, it doesn't work.
It works. Yep. We're going to square root a lot of negative numbers in here. What's the square root of a negative number? Starts with an I. No. It's imaginary. It's called non-real. It means it's an imaginary number. And we, Malia, are going to do a lot of non-real numbers in here, so you can't tell me that that just doesn't work. We're going to work a lot with that in the weeks to come. But as far as where it crosses the x-axis, if it's non-real there, it's not going to have any real zeros. So for your answer on something like this, when you get non-real, when it's you would say there are no real solutions. You can't just say no solutions, because we're fixing to be learning about imaginary solutions. So you got to throw that real in there. No real solutions.
So when you have x squared equals a negative number, it's not a real solution.
Correct.
So make a symbol for that.
There's the no solution symbol, but there's not one for no real solutions. Maybe we'll even get one day.
What's the no solution?
Zero with a slash. All right, that.
Isn't there a thing for all the numbers? Isn't it like that R? And I think you can put those together.
Possibly. All right, one more before we get back to some factoring stuff again. I got 2/5 times x plus 3 squared equals 5. All right. There are lots of things you could do on this. You could, if you wanted to try to start simplifying that thing down, that x plus 3 squared means you would write that twice. X plus 3 times x plus 3, and then you'd multiply those together. I would do it by using FOIL. Then there's a 2/5 out in front, so you would distribute a 2/5 to it. So you could start doing all of that junk to get it in standard form. You could. Or what I would do here is I would try to start simplifying it as it is. It's got 2/5 being multiplied to the whole thing. How can I undo the multiplication of 2/5? Divide. So I'm going to divide everything by 2/5. Now this is easy fraction stuff, because on this left side the 2/5 cancel out. When you divide by 2/5, that's the same as multiplying by its reciprocal, right? right? So that gets me x plus 3 squared equals 25 halves. Okay? Now, a lot of people will get to this step and they'll say, well, subtract 3 next. No, because that 3 is in the parentheses, and that whole parentheses is being squared. So that's what I would need to do now is undo the squared. We talked a couple of problems ago about undoing the squared. How do you undo a squared? Square root everything. So that's going to give me x plus 3 equals a positive or negative square root of 25 halves. Alright, when you square root a fraction like we've got over there, that means you have to take the square root of the numerator and the denominator, the top and the bottom. The top is easy. Square root of 25 is 5. So I've got x plus 3 equals positive or negative 5 over the square root of 2. Alright. 2, square root of 2. Square root of 2. How do I simplify square root of 2? What's the biggest perfect square that'll go into 2? 1, but that's 1 times 2, so you're still stuck with the 2 there, right? So you can't simplify that any. However, you cannot leave a radical on bottom. Okay, that's improper, whatever they call that. Can't leave a radical on bottom. So we've got to get rid of the square root of 2 on bottom. What could I multiply square root of 2 by that would cancel out the square root? Square root of 2. I can multiply it by itself. Okay, so this is going to give me, I'm going to multiply the bottom by square root of 2 and the top by the square root of 2. So I'm now going to have x plus 3 equals plus or minus on the top. What's 5 times the square root of 2?
I got a decimal.
It's just 5 square root of 2. On the bottom, what's the square root of 2 times the square root of 2? It's the square root of 4, which is 2. Okay? That will happen every time. Anytime you multiply a square root by itself, it just cancels the symbol out. Square root of 3 times the square root of 3 would be the square root of 9, which is 3. Macy?
Is this factoring by square root or
Solving by square roots. Alright, we were trying to solve for x. I can't simplify that anymore. Okay, because 5 over 2 doesn't reduce, so you can't simplify that anymore. But you got plus 3 still over there with the x. So what do I need to do to get the plus 3 out of the x? Subtract 3. I'm going to put that in the front when I subtract it. So I'm going to have negative 3 plus or minus 5 square root of 2 over 2. Now you need to make sure that you see that as 2 answers. Because that means that plus or minus means I could have negative 3 plus 5 square roots of 2 over 2. And I could have negative 3 minus 5 square roots of 2 over 2. See you tomorrow.